All right. Welcome back from lunch. I know it was a shorter lunch than we had planned, but thank you for making it back into this room. We really appreciate it. We're going to go ahead and get started. So welcome back. This is the restoration techniques session for today. In this session, we'll be hearing from some of the leading experts in restoration design of these marsh migration areas and of tidal wetland restoration in general. And really hearing about implementation techniques for marsh migration. There's been a great amount of lessons learned that we've all experienced over the years implementing these projects. And we're hoping while the engineering session was really thinking about slopes and dirt and the engineering side of the equation, we want to hear today about how you select your plant palette. And what are you thinking about when you're managing for those plants in terms of irrigation, in terms of soil treatment? We really want to understand planting techniques. So what are the best techniques that we are using, and how are we going to scale up to meet the need of getting these areas restored? So with that, we're going to hear from three speakers. First, we'll hear from Peter Baye. Peter is an independent coastal ecologist and botanist who has waded, hiked, paddled, and poked around most of the San Francisco estuaries, marshes, and shorelines for decades. I love that. During that time, he has worked on an excessive number of wetland and shoreline restoration and management projects and regional plans, including endangered species recovery as staff for federal regulatory and resource agencies, an independent consultant, and a technical advisor. Next, we'll hear from Jessie McKeen-Scott. Jessie is the Restoration Program Manager for Save the Bay's community-based restoration programs. She loves the smell of tarweed on her boots almost as much as she loves engaging the community in Save the Bay's restoration efforts. And last, we'll hear from Jeanne Hammond. Jeanne works for Olofson Environmental as a wildlife ecologist and biologist, and is the restoration program manager for the San Francisco Estuary Invasive Spartina project. Working on ISP for more than 15 years means she has spent a lot of time exploring San Francisco Bay's marshes and gets to be on airboats and in kayaks on a regular basis. I'm jealous. And so with that, we'll have...
Just coming back from lunch and lots of overstimulating conversations. I'm going to try to keep on my slides. So my talk is about aiming for a moving target, adapting tidal restoration methods and materials for rapidly shifting shores of the San Francisco Estuary. And it's about adapting nature-based methods and materials to tidal marsh restoration projects that have to cope with an accelerating pace of sea level rise, erosion, and climate variables, such as extreme heat waves, droughts that have affected implementation of a lot of our projects. And the reference to moving target really reflects my recent experience with some of the environmental baseline conditions of project sites that are changing faster than our planning processes and our permitting processes. So the sites we actually go out to work on are quite different from the ones we planned for. We have to do a lot of adaptive management, chaos management in the field just to keep on in line with our goals. And I'm finding at this end of my career, this is coming at an unprecedented pace from the last 10 years. And the image you see in front of you is really a step back to sort of a geologic timescale for a perspective. I think most of the talks so far have been focusing on habitat transition zones in the built environment, usually bayward of infrastructure. And I wanted to step back and give a larger perspective about how the constructed transition zones are facsimiles or surrogates for landscape features that, as Gavin pointed out, existed in a different scale. And just as a professional perspective, I think a lot of our work now in creating or designing habitat transition zone surrogates is really just to buy time. If I can paraphrase Jeremy Lowe's timelines of adaptation measures, we're buying some time for something else because we know these are transient adaptations, that these only give us so many inches or feet of sea level before they give out. So we need to look about what comes after these transitional steps. And this landscape perspective, which is Potrero Hills, gives that setting. although our eyes go to the uplands, the hill slopes, really, if you look at the flat end of the middle of the photo, those are the alluvial fans, flats, and plains. That is the transgressive platform. That's real estuarine transgression space. All of our estuaries migrated over these flat plains, which are almost uniformly fine-grained sediments, clays, many of them alkali. And the reason I'm bringing it up for where we're going with all this is that even during the most accelerated periods of sea level rise in the early Holocene to mid-Holocene, when sea level rise rates were 10 times what they were in the last couple centuries, and probably close to where we're going, these platforms sustained rapidly migrating marshes and without any construction. It's probably the only long-term viable solution, managed retreat. So I wanted to put this as context for why we're doing all of these high energy, high cost projects. We're buying a little bit of time so we can figure out a way to get around our infrastructure constraints so we can get tidal marshes reconnected to a landscape that can sustain them. Probably took too long on that title slide. So as far as plants go, I wanted to reframe plants as well, not just as sort of habitat or diversity frosting on the engineered cake of tidal restoration projects, but as geomorphic agents. They not only have their own species interactions and their own wildlife interactions, which we tend to hear of more, but they're also transformative agents of migrating estuarine shorelines. And I wanted to point out that the life forms of plants, species compositions, but the functional traits of plants in the historical grasslands that occupied these alluvial plains, flats, deltas, were not uniformly distributed. They were biased towards creeping perennial plants with moderate salt tolerance. One of the most important traits that unifies all of these lowland species is the prevalence of clonal growth patterns, creeping rhizomatous species. This isn't just a utility item for the way we grow them or what we'd like to see in the field. Clonal plants elevate their ability to tolerate salt and drought by spreading resources across clones. So at the leading edge of a rising high tide line, if an interconnected clone is exposed to a rising tide line, they move resources to buffer the impacts, the physiological stresses of that changing shoreline. The same traits, spreading roots and rhizomes, also enable them to bind soils to increase soil shear strength, which creates a resistance to erosion. These are specific to the traits of life forms in these lowland alluvial habitats. And it's not a question of what grows well on a levee or what grows fast or just what specific habitat attributes we'd like. These are geomorphic requisites for sustaining stability of transgressive estuarine shorelines. And these are, they're also not gone. We do have a number of remnant lowland ecosystems scattered around the estuary, some in the Nur, some at Point Pinole, and they do regenerate in our constructed terrestrial ecotones. So here are some examples of some of these alkali and salt tolerant creeping perennial species that bind and stabilize the edges of transgressive marshes. And they can succeed and have succeeded in some tidal marsh restoration sites. But most important, I think, is for this talk is their influence on erosion conditions. These contrast with upland species, which also can occur or can be planted in transition zones. Shrubs in particular from coastal bluff environments or hill slope environments, very different physiologically and very different growth forms. Tap-rooted plants, they have roots that dive deep to get water during droughts, which means that they don't increase soil shear strength in the shallow zones where tides can erode soil. It also means that they don't have salt tolerance. Some have salt spray tolerance, but none of the shrubs from coastal bluffs or hill slopes have any physiologically significant salt tolerance. So that means if they're planted on levees as surrogates for transgression, they may grow great in the short term and provide great high tide cover in the short term. But if we're planting them in the sweep zone of tidal marsh transgression, they have to collapse. They will get replaced by either the weeds that are numerically superior there, or if they're mixed with rhizomatous plants, they'll fill their gaps. But if you're concerned about stability of a tidal marsh shoreline, these are definitely species only for areas that you expect to be uplands within your professional lifetimes. Placing them down by the tidal edge is not always calculated risk. And it's important because, as you can see in the lower photo of Sears Point, where coyote brush, which is actually slightly salt tolerant relative to other shrubs, where it naturally spread on one of the levees downwind from some large seed sources, it smothered all other vegetation. And when erosion began to exert its effects on one of the levees, you can see those tap roots are fully exposed, they bind nothing around it, and the levee collapses at an accelerated rate for lack of that increased soil shear strength. So these are, I want to impress that vegetation is not just habitat diversity or wildlife habitat, it's a geomorphic agent. And in the absence of that geomorphic agency to buffer erosion, where there are sensitive infrastructure assets and engineers are required to protect them, if slopes, substrates, and vegetation aren't aligned for resilience in that predictable wetland migration zone, the default is rock armoring, because that's what's in the manuals. It's in the Corps' manuals, it's in most engineering manuals, and I think it should be self-evident that generally speaking, revetments and riprap are inimical to wetland migration. You can cap them, but it's hard to grow rhizomatous species in rock. They can grow in interstices to some extent, but we need to, it raises the premium on finding nature-based solutions that are more compatible with vegetated transition zones that can migrate. Holding the line is very different from building a platform for estuarine transgression or wetland migration. So I'll come back to the much discussed, pleased to hear this, Sears Point tidal restoration project. I'll sail past some of the background information you got from Steve and from Stuart. The key point, what you probably have already heard, is that the vegetative stabilization step was skipped. And so the full wind wave energy of a bed roughness of near zero, freshly graded basin, was exerted on the downwind ends of the levees. And they were dissipative shorelines, 10 to 1, 20 to 1 is pretty flat, but we got into a sort of vicious cycle, a positive feedback, where the lighter grains of unconsolidated bay mud lifted off, ate down to the more resistant, compacted lower layers of the levee foundation, which meant shallower roots, which meant that each wind wave erosion cycle made it easier to lift off the pioneer vegetation. So we got pioneer salt marsh every year, and it all went away the next year. So we're kind of in the stuck mode. As Steve pointed out, you know, the profile got more concave, more reflective. So we got into a vicious cycle that intensified erosion. And the short of the story is that that very expensive transition zone pretty much eroded out. So we needed to do an intervention that was not going to defeat the purpose of having that transition zone. Armoring would not be compatible with the multiple ecosystem and geomorphic design functions for that transition zone, which raises the premium again on finding nature-based solutions that would approximate what the original design would be. And I would point out, again, this is, as Steve said, a sort of a setback levee on the one side of the railroads. All of this contrivance for trying to get the functions of a transition zone. If you look at the lower photo of the 1856 T-sheet, US Coast Survey sheets, we were a couple hundred feet from the original alluvial fans. I mean, they were right behind the railroad levee. So we're just within reach of where this would be self-sustaining and require no engineering at all, but for the cooperation of railroad and some farmers who didn't want to quite finish out hay farming. So here's some views of the pre-construction north levee erosion. This is the downwind side. This is the maximum fetch. So we're looking at some hard hit shorelines. You can see that struggling little turret of pickleweed that shows you some of the elevation change that had occurred. You're really eating down to the compacted hard pan surface of that levee foundation. And So we were trying to figure out what we could do for nature-based methods, as Gavin said, that would fit the local context. So observing local processes, we noticed that some of the drying mud from that compacted levee surface was flaking off and doing what some arid Mediterranean coast marshes do. They create mud clasts. They're basically gravel and sand-sized pieces of cemented mud with high clay content. And they were functioning as lightweight pieces of gravel and sand and washing up and forming beaches, swash bars, some of which were becoming vegetated with very robust pickleweed, which, however, remained vulnerable to erosion at the bayward edge because, again, this whole thing is retreating landward. So yeah, it was like a dune. We're building vertically, getting vegetated, and getting undermined below the root zone on the seaward end. Also, a few volunteer pieces of large driftwood came in and created little wave shelter zones behind them. And it was those areas that did not erode out and actually concentrated wave shadow, wave refraction, builds little tombolos behind them of these sort of transient mud grains. We thought, well, might be able to work with that. If you can feed this process, add a lot, a lot more wood, a lot more mud clasts, and then perhaps limit the base level of that winter erosion so we didn't keep making it a more concave profile, we might be able to reverse the process. So to point out that driftwood is not just in the Pacific Northwest, it is all through San Francisco Bay. We probably are deficient in it because of all our flood control channels and bridges where, people regularly maintain and remove all that wood. But the Bay is basically a repository for driftwood, the same way North Coast estuaries are. We just don't have as many redwoods. But this is an old growth China Camp prehistoric tidal marsh. There's some very old large pieces of wood in there, and they also exert geomorphic effects. I should go back and point out that vegetation does climb over driftwood. It actually elevates the canopy. Pickleweed is a climbing plant when it has the opportunity. So there are opportunities to incorporate wood to elevate high tide refuge. Lastly, this is a narrower distribution vegetation type, but in parts of the Bay where we do have shale and sandstone cliffs raining down fragments of gravel onto marshes, or we have artificial sources of gravel, gravel deposited over rootable bay mud will grow marshes. And in fact, cobble salt marshes are very common on glaciated coasts and some coasts like in South America. It's kind of an off-brand marsh here, but they have surface lag deposits that are effectively immobile. That's how they form. All the finer sediments are washed away, and the coarsest stuff that will not move is left behind. It creates a cap over the erodible sediments. Vegetation grows either interstitially or it grows in that underlying layer, and it can provide a safe space for seedling recruitment. That's something we want to apply. So here's our artificial version of that to create a stable, temporarily stable surface for seedling recruitment and to prevent further downcutting of that levee bench. This is after we already lost a lot. It takes a while to ramp up funding and design and permitting. So we were continuing to hemorrhage the profile during the planning phase. This was kind of painful to watch. But by the time we got to construction in 2021, worked with the construction crews, the foremen, to develop ways of depositing thin layers of gravel that would adhere to the bay mud without smothering the plants. That's a trick. When you deposit quote, thin layer sediment, sometimes it flattens the vegetation and it sets you back. So we worked with the construction crews to develop ways to non-destructively place coarse sediments, and it was very successful. We did the same thing with the bay mud clasts. We took crushed, dried, adobe-like bay mud from 30-year-old dredge spoil piles that were just happened to be down the street at Port Sonoma. They were crushed and rained over, sort of precipitation method. Excavator bucket was shaken and drawn over, and standing cordgrass and pickleweed would just grow through the same. I should point out that the same physiological traits of clonal plants that enable them to tolerate salts also enables them to tolerate burial. They can move resources around. So partial burial, non-destructive. And what it ended up doing between the gravel layer and the bay mud, granular bay mud, the aggregate bay mud, it created a buffer, a mantle that allowed vegetation to grow 2 years instead of staying at the seedling juvenile stage. You'll see the effects. Finally, as an alternative to constructed sacrificial berms, which do affect drainage networks and high tide refugia distributions and predator distributions, we tried to use recycled, as Stuart mentioned, eucalyptus wood, which when seasoned is completely non-toxic. It's very dense, it doesn't float off, it's almost non-buoyant when it's wet. And those were fastened in to the surface to make low-crested brave wakes, as well as platforms for vegetation. And finally, we added that gravel and sand not to create beaches, but to create successional beach to high marsh zones. So the idea was to place gravel and sand beaches with the intention of having them become colonized rapidly. Finally, this is more mitigation than revegetation, but where we disturbed the levees and had to grade down to create those smooth ramp profiles where the unstable scarps had been, we took something that came from Ducks Unlimited construction from the original project, where there was an incidental incorporation of rhizome fragments of creeping wild rye, which is one of the principal alkali grassland species. They were distributed over a mile of levee just by earth moving. There was no planting involved. And some of the largest stands of creeping wild rye in Sonoma County are now on the back slope. But we kind of borrowed them, recycled them, and just incorporated them in the grading. No planting at all, partly as mitigation measure. And Save the Bay did a more deliberate job of this, the Ravenswood levee, and they can talk about that. So this is what it looked like in fall 2021, right after construction. You can still see there is some residual vegetation that was not destroyed by all the mud-classed placement and gravel placement. You can see some brush fences in the upper mud flats that I'm not talking about. And you can see waves have already started to smooth over these sediments, jumping to the conclusion. This is what it looked like with great relief the first year, because we had a lot of southerly tracking storms. Our levees were directly facing those southerly storms. This is 2021, 200, according to Becca Morris, Stuart's graduate student, 225% increase in tidal marsh vegetation. You can see the graded ramp is completely vegetated. Pickleweed is overtopping the logs in the first year. You can also see cordgrass has moved in pretty close to the levee. So we've lost, this is all design transition zone. So it's kind of doing what it was designed to do with a foot of sea level rise, which has become marsh, but it did that in a couple of years from erosion alone, which is a side effect. This is September, this is last month. You can't really see many of the logs. They are all overgrown with sediment. So I would just disagree with one thing Stuart said, that we were kind of like spreading our risks with all these devices. Each one of these measures interacted with the next. The driftwood interacted with the placement of the mud clasts. They became centers of deposition. So each of the lower intertidal modifications set up conditions for the ones above it. And the result is, despite an incredibly intensive back-to-back southerly storm track year, that whole area that had been stuck in positive feedback cycles for a good 5 years is pretty much completely stabilized. It's actually accreting now, partly because of the wind wave reworking of the mud clasts. And here is a vegetation map made from remote sensing, showing some of the distribution. The green is the denser cover classes. You can see that's really increased, and the lower density stuff is catching up. And right now, I'd say it's all on a trajectory for full stabilization. Again, it's kind of keeping us from hemorrhaging out those losses. This is not unique to Sears Point. Almost all of the bay's fringing marshes are retreating at an astonishing and largely unmonitored rate. I think Stuart pointed out Lisa Shiley's model of China Camp. That assumes boundary conditions are stable, that the marsh edges are not eroding faster. But as we know worldwide, the greatest losses of salt marshes are not from drowning. They can keep up vertically. They are not keeping up horizontally. We really need to watch not just the migration of the upland boundary of marshes, but particularly the outer edges. We think some of these local adaptation techniques to non-destructively resist erosion, slow erosion down, not stop it, not hold the line, but moderate the rate of retreat, can help buy us more time for our existing fringing marshes until we can get a long-term transgressive solution in place. Am I over time?
You're perfect.
Oh,
yes.
That's a first. All right.
You had some backup slides, right? So
I did, in case questions.
Here we go. Yes.
Awesome. Hi, everyone. Thanks so much for having me. It's really exciting to be here in this group of people doing work in so many different ways in support of the same thing. So I'm really happy to be here. Today, I'm going to be talking specifically about the revegetation work and the lessons learned from a project led by Save the Bay down at the Ravenswood R4 pond. Briefly, for a little context on Save the Bay's work, we've been doing restoration along the Martin Luther King Jr. shoreline in Oakland and the Palo Alto Baylands for nearly 20 years. And the sites we're working on there are on a much smaller scale. They're typically less than 1 acre, and we're really using these sites to engage the public in our work. So we have education programs, we have corporate programs come out, and community groups, and we're really giving folks the opportunity to get hands-on experience in our nurseries and at these sites doing that restoration work. But over the years, we of course realized the really urgent need for more rapid and more large-scale transition zone restoration projects. We had the opportunity to work on the Oraloma horizontal levee demonstration project, which is pictured here. For that project, we were really amplifying perennial rhizomatous material on a short time scale to establish itself on this site. The methods that we used and the lessons we learned in that process helped us learn techniques for more of that large scale and, again, lower cost transition zone habitat restoration that we've been able to apply moving forward, most notably at the Ravenswood R4 levee. So again, a picture of Ravenswood, exciting to hear about its construction earlier. Ravenswood for us is a large transition zone site that we are responsible for actually restoring 2 transition zones on. The first, if this pointer works, is this area right here, which is the R4 levee. It's a 9-acre site that we started restoring in fall and winter of 2021. And the second site that we're working on, or will be soon, is right along here. This is the All-American Canal site. It's a 16-acre site that we're going to be starting to revegetate this fall and winter. And I do want to note right now that at this time, neither of these sites are actually exposed to the tides. We're hoping that a levee breach will be happening soon, but right now they're not actually up against any water except for fresh water that's been sitting there from all the rain this winter. Part of this project also included a large division bed nursery that we established adjacent to the site, kind of right over in this area, with a partnership with West Bay Sanitary District, who manages the land. And when I think of this division bed nursery, I sort of think of it as your raised bed backyard garden, but on a really big scale. It includes 84 beds that are filled with a palette of rhizomatous perennial native species that, as Peter mentioned, are able to migrate and move upslope when we put them into a transition zone. 2 huge benefits of this division bed method, which was new to us at Save the Bay, are really cost and capacity. In a container bed nursery, which we also have, it typically costs anywhere between $1.50 to $10 per container grown plant over the course of its lifetime in that container bed nursery. And that's due to the staff time and labor associated with that work, as well as the infrastructure to have that nursery operating and keep it really clean. Between the 2 nurseries that Save the Bay runs as container plant nurseries, we're also only able to grow around 40,000 plants per year in that whole nursery. With these division beds, however, we're able to grow thousands of plants per bed. So looking at the space that these beds are taking up, it's much less space to grow thousands and thousands of plants. And it's also a much lower cost. We built this nursery, we harvested rhizomatous material from local sources, put it into the beds, irrigated them, and they're cloning and replicating themselves kind of on their own over time. It takes a lot less maintenance on our part and a lot less time to maintain that nursery. And another benefit of having this on-site nursery as part of this project is that it's really close to where those plants are getting outplanted. So when it comes to actually transporting stuff to the site, it's going to save us, again, a lot of time and labor. So the revegetation methods and the species selection for this project were directly guided by Peter Baye. So I'm so excited that he got to talk to you about everything first. We basically had 4 phases of planting for this project, and each planting phase had a unique set of species that were being selected for that phase based on how they were being outplanted, as well as the general goals of the restoration project. And so you can see sort of those phases and those groupings here. Our clonal meadow species were really stress tolerant and abundant in our nursery because they were going to be outplanted using mechanized equipment. We had diversity patch species that provide pollinator habitat, increase cover, and add biodiversity to that landscape. We had refuge patch species, which, as their name suggests, provide that high tide refugia. And then we also had annual cover crop that we sprinkled across the slope to cover that bare ground and try and outcompete the non-native invasives that might establish themselves on the slope. I do want to note that in this planting, we really focused a lot less on shrubby natives than we had in the past. In the past, we planted a lot of coastal sage on our sites. And after witnessing a pattern of that coastal sage being exposed to the migrating salt levels, they would die off. And we wanted to really make sure not to include those types of species in this outplanting plan. And I just love this picture here. This is a little cross section of that rhizomatous material cut out of one of our beds. Because of COVID, they had an extra long time to grow and just got so densely packed in there. And I think this is a great photo showing just how dense that grows. Here you can see just an overview of our planting timeline for the Ravenswood R4 revegetation. We were doing this again in the fall and winter of 2021, so had some extra COVID restrictions in place, which means that we were also not able to engage the public in this project like we originally intended. So this timeline is basically led by 7 Save the Bay staff members, 1 farmer who came out to help us with a ton of our work, and 4 what we call super volunteers who have been working with us for a long time. So in October and November, we were really focused on site and sod preparation. Site preparation meant having the farmer that we partnered with, Frank Imhoff, come out to the site and first disc the slope to remove any non-native invasives that were established on the slope. Part of that process also helped break up the soil, which had been compacted just due to the grading process, and make it easier and looser for plants to go into it. In the meantime, while that was happening, our staff was working in the nursery, starting specifically with our clonal meadow species division beds. The clonal meadow species that we were planting were creeping wild rye, western ragweed, saltgrass, and alkali heath. And I just want you to recall quickly that these species were selected because they were able to handle a great deal of physical disturbance. We collected them from local sources, we planted them into the nursery. In this portion, we were dividing them and then outplanting them again. And we really wanted to test on this project whether they were able to withstand the stress of mechanized planting, which was different than the hand planting we'd been used to. So we had beds full of these rhizomes, and you can see here my colleague Charlie is using a trowel to cut out 6 by 18 inch pieces of sod from those beds. Those sod pieces were then translocated to the slope where we tracked how many of each species were getting put into each of our transects. You can see lots of pieces of sod here. So after clonal meadow sod pieces were laid by hand across the slope, we then had our farmer come back to the site and disc these species in with a tractor and discer, which you can see pictured really well in this bottom left photo. And for those of you who aren't as familiar with what a disker is, it's basically a giant spiral blade that kind of is dragged behind a tractor and cuts up whatever is in its path. So when it rolled over the slope, it was breaking up that soil in the previous steps. And in this case, it was coming and rolling over those 6 by 18-inch pieces of sod, cutting them up further and helping spread them even farther across the slope so that they could establish themselves and continue to grow. With this process of the disker, we were able to plant in 3 afternoons the same amount of plant material that would normally take us over a full season of outplanting to get in the ground. So again, 3 days, what would normally take over 1 season, which was really incredible. We then came in, and because the slope, as you can see, was really bare at this point and just had little rhizomes spread out all over the place, we came in and dispersed an annual seed mix across the slope, timing this dispersal as close as we could with the rain so that they would really get that water and be able to grow. And in this bottom picture, you can see some beautiful Amsynchia popping up everywhere. And that was the slope in April of 2022. So really starting to establish itself. In the next planting phase, we hand planted 3,860 sod pieces in diversity patches across the slope. These were species that were less abundant in our nursery, a little bit less stress tolerant to that mechanized planting process, but provided additional ecosystem services like pollinator habitat, and of course, increased biodiversity from the 4 clonal meadow species that we were planting with the disker. These diversity patches included species like yarrow, mugwort, marsh boccharis, and western goldenrod, among others. And you can see sort of these 5 by 5 patches that we were planting them in, iterated across the slope. And then finally, we did plant some container plants because we have 2 container plant nurseries. And we planted 3,800 container plants across predicted channels on the slope to provide that dense shrubby high tide refugia in the tidal marsh. And some of the species we included in that planting palette were California rose, California blackberry, and a lot of marsh gum plant. And then we hoped for rain. We tried to water and irrigate as much as we could, and we weeded throughout the spring. Now, as I touched on really briefly in the beginning, engaging the community in our work is a really big part of Save the Bay's mission and of our habitat restoration goals. Of course, COVID-19 postponed our ability to bring people out to the site to work with us. So the first time we could really engage volunteers on site was spring of 2022. And the Ravenswood R4 levee is also just a little bit farther away from anywhere where the public can drive up to, which made it a little harder for us to engage school programs and young students. It just takes a little longer and it's a little harder for them to walk to the site. But it really expanded our ability to engage and educate adults on these programs. So we've had a lot of corporate groups come out and a lot of public programs come out where adults are learning about marsh migration and nature-based solutions, which has been exciting. And just for some context, since spring of 2022, when we first got people out there, we've had about 500 volunteers come out and support our work, which is cool. So it's been a big project. It's an ongoing project, and we've definitely learned a lot and are continuing to learn through this process. And so just wanted to highlight some of the successes that we've had. First of all, that annual seed mix that we spread across the slope was hugely successful. It provided that dense coverage and did outcompete a lot of the non-natives that were trying to get established on the slope. It also has reseeded itself and so keeps coming up year after year. And last week we were out monitoring the site and we're just, again, covered in tarweed at the end of the day because how much is on site. The perennial rhizomatous sod pieces that we mechanically disked into the slope have also had a high rate of survival, which is really exciting. And they're starting to spread. So that's good news. And the diversity patch species also had a high rate of survival. So we're seeing all of these things coming up and continuing to spread. And of course, with the limitations of COVID, we affirmed what we already knew, which is that we have a really excellent team who's dedicated and methodical and can do this hard work. We also really better understand the constraints of this work. Yes, the planting labor was decreased by using the disker and contracting with a farmer, but the labor of physically cutting the sod out of those beds and then transporting it to the slope is a lot of physical work for a small team. We were constrained by COVID in the number of volunteers that we were able to engage, but in this upcoming year, we're hoping to really engage more community members in that hands-on work and get some additional help doing that sod preparation in the nurseries. There was also a high volume of non-native seeds that were already established in the soil that we got on site. And so we're kind of constantly working on holding back the clover, holding back whatever has established itself already. And while this year's heavy rains were really exciting and we saw a lot of growth on the slope, we can't count on that in a drought-stricken California. And the ability of our team to irrigate the slope when it is a drought season is just really, really difficult. So that is certainly a constraint. As we look ahead, we hope to continue learning and refining this process for large-scale, low-cost transition zone habitat restoration to really make that goal of restoring 100,000 acres of marshland around the San Francisco Bay more feasible and more fast. We are going to iterate the plan that we used along the R4 levee at the All-American Canal site this winter. And we'll be working with a lot more community engagement, having community members come out, as well as having a partnership with the San Jose Conservation Corps to do a lot of this work and to train folks on that. We also have been and are going to continue to monitor both the R4 site and soon the All-American Canal site, and are going to be analyzing data in the next couple of years to better understand the successes and constraints on the site, and look forward to comparing what that means right now before the levee has been breached, as well as after. And then, of course, we hope to continue engaging in spaces like this, where we're learning from each other and being able to apply that moving forward. So just a big shout out to the team, to the many, many site partners that went into this project, and to our volunteers. And I'm happy to answer any questions after all of the sessions are done.
Ready to go. So hi, I'm Jeanne Hammond and I'm with Olofson Environmental, and I'm going to be talking to you today about some of the work that the Invasive Spartina project has been doing to enhance older restored marsh upland transition zones. So first, I'm sure almost all of you in the room are familiar with the Invasive Spartina project, but in case you're not, it's a very big, very many partner-led project. And the primary partners are the State Coastal Conservancy and the U.S. Fish and Wildlife Service, and then the California Invasive Plant Council and Olofson Environmental, who I work for, manage and do the project on the ground. And I can't do a talk without including a picture of native Pacific cordgrass, Spartina foliosa. And I just wanted to, so this talk is going to be kind of from a different lens, in that the Invasive Spartina project, our main goal is to control and eradicate Invasive Spartina from the San Francisco Estuary. So this species is what we're trying to protect, and also all of the other native tidal marsh species that are threatened by the spread of Invasive Spartina. And so our restoration program basically supports the inventory and treatment of invasive Spartina. It's been going on for about 13 years. It's ongoing. And because invasive Spartina has been present throughout the estuary, we're working at a Bay-wide scale. We're trying to think of the best places we can work. And because the spread of invasive Spartina created these sites where there was a lot of space for ridgeways rail to move in and other sensitive species, we're looking at, the effects and impacts from removal and the habitat loss. And so we're really focusing on the critical components of how do we enhance rail habitat. And those are covered from predators, for foraging, through the whole life cycle, through nesting, and then what I'm going to be talking about today, which is high tide refuge. And once again, our focus is on rapid enhancement. We want to be able to move our program as quickly as possible. So trying to enhance habitat quickly. So this is kind of an overview of habitat enhancements. The picture on the left is showing you the 40+ sites we've worked at in blue. We've installed over 500,000 plantings.
We work in, across the marsh. So we're looking at the low marsh, we're installing Pacific cordgrass, the mid to high marsh, marsh gum plant. We're focusing on some of that, what Gavin was talking about, the in-marsh refugia that can be provided by gum plant along the marsh channels. So bringing that into restoration sites where it's not present yet. And then what I'm going to be focusing on today is the high tide refuge. So the project has done two different things to kind of provide in-marsh high tide refuge, and H.D. Harvey and Associates helped design and implement one of them, which is these small habitat features called high tide refuge islands. And we put 82 of those in 16 different sites. And then what I'm going to be talking about is the work that we just started 2 years ago. So this is kind of brand new to us, planting transition zones in these older restoration sites. And so thinking about, like, once again, from our lens, what's important to us is being able to move this Spartina project forward. So our site selection has been really focused on where we can help enhance functional native habitat for California ridgeways rail and other, tidal marsh dependent wildlife. Once again, we're focusing on those critical components. I'm talking about the high tide refuge today that the transition zones provide. And once again, focusing on sites where invasive Spartina removal may have caused habitat loss, or we know has caused habitat loss. And what we end up working in is these older restoration sites where invasive Spartina came in, became a monoculture, and now that we've removed it, there's really no habitat because there wasn't any habitat before. And all of those older restoration sites also have these very narrow transition zones that are constructed as part of the restoration. And unfortunately, they haven't been maintained as habitat. So they're ruderal species, monocultures of mustard or wild radish or Italian thistle, Detrichia, all those lovely plants you don't want to have to deal with, but you have to at these sites. And then the last thing that we're thinking about is we're trying to complement other organizations that are working in this space, like Save the Bay and STRAW and San Francisco Bay Bird Observatory. So focusing on more difficult to access site, we're already out in the marshes. We know how to do it. We have the permits. And also, places that are just not ever going to be suitable for volunteers to go to. So we're really trying to focus on those. And I don't know that I mentioned this, but besides the narrow transition zones that are on these edges, we do have some opportunities in the marsh where habitat features were constructed that are higher elevation. This is an example of one on East Bay Regional Park District land at Hayward Regional Shoreline in the middle of Cogswell. There's several Cogswell quadrants, and they're these constructed islands that are very large, and primarily they're vegetated with non-native species. So coming in there and trying to enhance them. And I don't have a picture of any of these features before we started enhancing, so I can't show you a picture that's all mustard. I don't know why, but I don't. And you can see this is a view from the east looking westward, as you can see in the diagram, whoops, showing where we've done our planting. So we've planted at the site for 2 years. And you can already see the green in the foreground on the island is all of the plantings that we've done, minus that the coyote brush in the middle, that was there already. So how do you enhance these older restoration T-zones that, they've existed for a long time and they have a really, really persistent seed bank of weeds? Looking at it from the perspective of how you're managing it for tidal marsh birds, Point Blue Conservation Science and partners Save the Bay and San Francisco Bay Bird Observatory, this study where they came up with restoration recommendations, for tidal marsh birds, but in the T-zone, what existing T-zones and what they provide and how you can manage them better for tidal marsh birds. Of course, a lot of these are obvious: dense vegetation, tall plants, wider transition zones. This is what everyone's working towards. They found that steep levees do have benefits. Wide is better, but there's really no negative effect of steep slope transition zone, especially if you're enhancing it and trying to provide some of those habitat characteristics that birds and other wildlife need. Multiple species is good, so monoculture of mustard, maybe not so good, and grasses can be beneficial. And so looking at it from the perspective of, all the transition zones that we're working with at the 6 sites that we decided to work at so far are these monocultures of weeds. So what are we going to do about that? Well, everybody's using, Peter and Jesse have talked about this, the idea of competitive planting or using these hardy salt tolerant, weedy natives. So we've focused on rhizonomous perennial forbs and grasses with the idea that they're going to be, growing laterally and forming a really great mat underground that's going to not only provide geomorphic capability for the site, but also outcompete the weeds. So hopefully you get less germination from that seed bank, and over time, as they expand and spread across the site, you'll eventually start to outcompete the weeds, or at least that's the hope. And then once again, we're trying to do this rapidly. So we're planting these rhizomatous plants in dense planting designs. And so far, we've only used container plants. We'd like to do other things, but because of this persistent seed bank, and as you can see in both of these pictures I have up here, we just weren't sure how those seed mixes would do. So we're focused on container plants so we can just manage the weeding better, essentially. So here's our planting designs, once again, planting very densely. Another thing that we do is, because we're working out in these spaces that aren't as easy to get to with volunteers, we use contractors. And so our planting designs are very consistent. We can mix it up on the site, but we're doing the same thing everywhere. So it's easy for the contractors to be able to go, be very efficient. They go to that yellow flag, they know that's where Bacchus glutinosa gets planted every time. There's 20 plants and it's in this configuration, and boom, you're done. And so we're focusing on dense single species clusters, and then these tall and or spreading perennials to help out compete the weeds. And hopefully those will spread across the site over time. Planting process is going to be really similar to all the other restoration practitioners that are working out there. We start thinking about propagation the year before, and then you get your final plant delivery to the sites by January 31st. One thing that we're dealing with on all of these sites is that we're adjacent to or trying to access across occupied tidal marsh habitats. So these are, existing sites with ridgeways rail populations. So we have a lot of constraints around that. So we're doing all of our site prep and ground truthing basically from November through January 31st, and then we're done for the year. Our planting by contractors happens in November to January 31st as well. And then we're going to be doing some targeted weeding and treating edges in some of the sites that we can still get access to. And then watering, like Jesse said, super important, especially with the dry cycles that we're going to be experiencing more and more. Although it seems like this last winter was such a lovely surprise and wonderful. But in our first year, so we've done this for 2 years. In our first year, we basically had to water, the ground was so dry and crumbly that we had to water the plants in, and we had to water them all the way through June, with some episodes of rain where, basically instead of having the wet winter that we had, it was the reverse. We had a little bit of rain and a lot of dry. But then this year we had the reverse, which is we didn't really need to water at all, but boy, did we need to weed. So this is showing just some more information about that site prep and maintenance that we do. And this is showing a transition zone at Citation Marsh before we did our site prep. So it's just this, mile-long segment of mustard. And then coming in and weed whacking and doing planting in that zone. And the main thing I want to say about this is, I already alluded to this, the constraints of working in and adjacent to endangered species habitats. We've got salt marsh harvest mouse and ridgeways rails. So, we have to have trained biologists out there at all times monitoring our activities, clearing work areas before we do them. And then the timing for any kind of more land disturbing activities like weed whacking and actual planting, we're limited. We're not doing that during the ridgeways rail breeding season. And another thing is, these are more difficult sites to get to. So the logistics of wet weather and clay on levees, you just can't drive once it starts raining. So something to think about. This is some pictures from this year showing the level of weeding that we had to do at some of our sites. Citation in particular has a really big mustard problem. Cogswell C, the one in the upper right, you can see that's a plot of creeping wildfire that we planted in January, and this is in May, and it's really tall and happy and probably a lot of height, basically competing with that mustard before we were able to get out there and weed that site. But you can see that the long linear dense planting design that we're doing, and as that grows together, hopefully it'll start to outcompete some of the weeds. And then the two lower pictures are creeping wild rye that was planted 2 years ago, and you can see it's already spread. It's no longer showing that linear planting design that we have in the photo above. It's starting to spread, spread both laterally in all directions, and it's grown together. So very helpful for getting to be good competitors with the wades. This is also another slide showing some of our plantings. These are 2-year-old plantings. And in the lower right-hand side, you can really start to see that kind of mosaic multiple species habitat cover that's going to provide good habitat for rails and other wildlife. Watering, Jesse mentioned this too. We only water our plants the first spring after we planted them, and max 2 times per month, ending June 30th. Once again, constraints working in endangered species habitat. So the no watering after June 30th is sort of a compromise between what most projects want to do, which is water forever, but you really want to mimic the natural cycle of these plants, and they're going to have to deal with the fact that our Mediterranean climate means we don't get rain in the summer. So planting just long enough so that they can get established, but then also letting them go dormant before the summer months that are so dry. And this is just, we did do a very small pilot project at the beginning of our program where we planted creeping wild rye. And this is very few plugs in a number of plots. There are about 24 plugs that we put out here back in 2012-13. And we didn't do any weeding of this. We didn't do any watering. And now we've got creeping wild rye that's spread just over a big amount of ground on this island, which is really gratifying to see that it actually, like, this competitive planning idea could work. And these are just some monitoring results from our first 2 years. We use photo points, and then we also do survivorship monitoring. The top left and the bottom left photos are basically taken right before planting, so you can see those flags showing where the plots were going to go. And then, and I think my labels are actually screwed up. So yeah, so the top left is from January 2022, and then the second photo is from that fall, and then the third photo is from this fall. So you can see the progression, the growth of the plants. And then the bottom one is actually just plants that were planted in January and showing what they look like now in September. So you're seeing a lot of Baccharis sculettinosa spread at the site. It's the same thing going across in time at a site in City of San Leandro, showing first fall and second fall above. And then on the lower one is showing just plants that were planted in January and now again in September. And you can see the growth. Oops, keep touching things. You can see the growth of the Baccharis sculettinosa and the creeping wild rye just from basically January until September. 2 more photos. The left-hand one is showing the spread of the creeping wild rye along this transition zone. These are plants that were planted 2 years ago, so 2 growing seasons. And the right-hand one is showing some Baccharis sculettinosa and also some Euthymia occidentalis. Those are planted in January after weeding. But you can also see what we're still dealing with at this site in the background. So this is a really long transition zone that we're just going to keep working at. We've got mustard above, so we'll have mustard issues there for a long time. So some lessons learned. We had really high survivorship in almost all of our plots at most of our sites, 90 to 100% survivorship both years. So watering and/or you get a wet winter, the plants love it. So do the weeds. And there's also lots of expansion in our 21-22 plots. Competitive planting is the way to go. Plant those weedy natives, plant rhizonomous perennials that spread. Hopefully they can survive dry years, bounce back in wet years, because they do have that rhizonomous root structure underneath the ground that can persist. Plant high density, single species plots. It's easier to deal with. They can grow together quickly. They're going to compete with the weeds better. And then all of the site-specific conditions and contacts that everyone's been talking about. Mine are a little more specific in the sense of, access and logistics can be really difficult at these sites. They get wet, you can't drive. Soil conditions, like what's going on there. All of these levee sites that we're working at were compacted probably during constructions, and we're dealing with them 20 years later. So, how to deal with that. There's going to be all sorts of preparation and maintenance with these existing levees. wet years, more weeding effort, constraints on timing and activities, and then watering. Just plan for the dry years, and then you can reallocate your effort to weeding in the wet years. This is what we found out in the 2 years we've been doing it. I think that's it. I would say the one thing that seems really important to me is we're talking about how important it is to do these large scale, brand new levee sites that are occurring around. We're making wider transition zones, but let's not neglect a lot of these older restoration sites where there isn't any migration space, but we need to do something to help support these real populations until we figure out what we're doing. It's just, there's so many sites where the transition zones are just weeds. So, and I'd like to thank all our partners and the dedicated ISP staff that does a lot of this work.